So, thanks for having me. We've heard a lot about telecom programmable telcos, and today I will tell you a little bit about testing of these programmable telcos. Because, you know, we used to be obsessive about testing in the telco industry, like 30 years ago, 40 years ago. But we're not anymore. Actually, we suck at testing nowadays. And we're going to do a little bit of a deep dive first into, like, in a general way, why we are actually testing, and then we'll go for some technical approaches on how we see testing in the telco industry and how we provide tools in order to help you guys. So I'm Andreas. I'm working since over 20 years in the telco industry, doing sipp since the very beginning. I've invented rtpengine like 12-13 years ago, which nowadays, thanks to Alan's awesome survey, is the #1 media relay in the open source world. I've done a lot of contributions in kamailio, like code contributions. I have co-founded a company in the past where we built telco systems, soft switches, right? And I've worked in at operators, actually operating these kind of systems as well. So I've seen a lot of things, and they are not pretty. Yeah. And what we were set out with Sipfront is that we were trying to solve our own issues, trying to provide tools that we would actually have needed back then in order to help us to develop telecom systems and to operate telecom systems. So there's always the question between testing and monitoring, right? So why do we test? Why do we monitor? Is there a difference? Is it the same? In my opinion, it's actually two sides of the same coin, right? So from a testing perspective, it's like, you know, particularly if you have automated testing, it's like, yeah, you provide a trigger to stop certain workflows, right? So if you do code development, for instance, or if you do automated deployments, you want to run all of these kind of tests in order to not, you know, deploy some regressions. And if something goes wrong, you stop, right? Whereas with monitoring, it's more like you run it 24/7 all the time, and if something goes wrong, then you start something. You start workflows, you start alerting, you start your troubleshooting workflows. It's the same tools that you can use, and I will show you some examples of how we are approaching this and which kind of tools we are using, so you can try to leverage them as well. All right, so why do we test? If we as technicians look at that, then we always think like, yeah, well, it's to check if the correct call flows are being signaled, if we get the right response codes for our sipp calls, if we are within certain thresholds with our RTP streams. But actually, and that's my experience from the last 20 years, it's more like about us as people being just more comfortable when working, right? Because when I, as a developer, was doing like night shifts as an operator at 3 in the morning, rolling out new software, I was like very deep into it, and at 4 or 5 in the morning I was tired, I was done, and I was like hopefully done with my job as well. But I had actually no idea whether the thing that I did, the software upgrade, the new feature that I rolled out, whether that actually worked. So the last thing I really wanted to do is, you know, grab an Excel sheet, have like my 20, 30, 40 core scenarios, pick up a phone and do like all the test cores by myself. And then figuring out in the end that something does not work, and then it was already 6 in the morning, and I was like, ooh, so are we gonna roll back? I have no idea, right? And if I say, okay, well, it will work, it doesn't matter, and then go to sleep, then I was never quite sure whether at 9 in the morning, you know, my boss was calling me out of bed saying, hey, the thing you did in the night, it's actually completely screwing up our customers. And it's the same for us as product managers, right? I mean, we are responsible for rolling out these kind of features, and we need to have like clear go, no-go decisions. When my developers, when my web engineers are doing their work in the night, I want to get a report in the end where it just says, okay, everything works, or I tell them, hey, stop, roll back, right? And also, if something goes wrong, that I actually know, in particular, where to focus my efforts on when we do our replanning of our features. And very important, also as an operations manager, if web engineers were doing their job and they screwed something up for whatever reason, then next day in the morning, I'm in my office, and suddenly first level starts escalating, saying, hey, this and this and these things don't work, we get tons of tickets, customers start calling in, my boss is standing on my shoes saying, hey, what's happening? And you don't have any answers. Probably your boss just told you that something is wrong, you didn't know before, right? And that is actually something that you really want to avoid. So, what we actually want to do with this testing and the monitoring is we want to get back in control. Eventually, we want to know whether RTP is fine and whether sipp is fine. But the actual goal is that I can just do my job and know when something is happening, right? Like with the story of me 4 in the morning doing my upgrades. What I actually wanted to do is just pressing a button somewhere saying, run all these tests, I go grab a coffee, 15 minutes later I'm back, saying, oh, all good, go to bed. Or I need to either fix it or roll it back. And the same with the product manager, right? He gets the report, she gets the report, saying, hey, we're not going to risk that, roll back. And as an operations manager, you actually, get your peace of mind and knowing all the time, okay, these and these and these things are not working, or they are working, which is also pretty important, right? You just want not this kind of uncertainty all the time. So is it really working? I know of people running companies that from time to time pick up the phone and try to do a call just checking if everything is good, right? And you just don't want to do that. What you want to do is you want to know when everything is fine, and you also want to know if something goes wrong and things just go wrong, that you know what goes wrong, right? That you have something to point at, oh, it's this particular interconnect, it's this SIP chunk, it's this customer segment or this feature that doesn't work, and then I can get back in control, and then I can say, hey, guys, you're going to look at this, this, and this, and then you're not there saying, oh, I have no idea what's going on, rather than you have answers for your customers and for your boss, right? So, what does it mean when we look at testing? So how do we get in this kind of control state? From my point of view, it's just 3 simple steps, and a lot it's common sense, right? We all know it, we just need to do it. And what we need to do is, first of all, we need to establish passive monitoring. I guess a lot of you guys already have that in place, right? It's just, tapping all the cars that are out there, just checking what's going on. If something goes wrong, I can look into that. Active monitoring, just doing, synthetic tests all the time, day in, day out, just checking if cars connect or not, depending on what you want. And just have a dashboard somewhere saying, okay, everything is good. And then you have ad hoc testing, where you empower your support engineers that they can, create and reproduce tests as well. Or as a developer, just saying, okay, I have a very specific and difficult test scenario. I just want to test exactly that, and I want to test that exactly once. So there's no need to schedule this. Now, when we are looking at passive monitoring in particular as a first pillar of that, there are fantastic tools out there. And I'm sure you have heard of most of them. So, for instance, there's Homer. There's Epic as a commercial instance, right? There's Web Monitor. There's Sipfront. Because when something really goes wrong in that kind of cost scenarios, you want to have some kind of these tools where you just go in and say, okay, what exactly did not work? There's a funny story. Like 15 years ago, I was working at an operator, and it was like still the early days of SIP. And I was developing things, developing features, and I was acting as third level support. And sometimes issues got escalated, first level, second level, and then it was like me, and they said like, come on, there's something wrong, we have no idea, fix it. So what I did was, I was actually calling up the customer, saying, hey, I know you have a problem, I just logged into the system, started a trace, can you please try it again? Yeah? Because I had no idea what's going on. Yeah? And particularly as a young technician, it's pretty awkward, right, to call your customers. It's bad. But you actually needed it to identify the actual issue, so that you could hopefully fix this. Active monitoring. That is actually about, as I said, for instance, you as an operations manager, you just want to know day in, day out if things work. Yeah? It's not like 30 years ago where you just punch in some numbers and A equals B and that's about it. Rather than, we have like all kind of different and more complex scenarios out there. Yeah? And you just want to know if they work because you have like tons of components. When we do our testing, we have like, I don't know, 20, 30 cloud components from AWS, from this, from that, and Grafana, and whatever, right? There are so many floating parts out there that could fail in such a system, and you just want to know if they work or not. Yeah? And in order to do our active testing, we leverage a lot of open source tools. There are fantastic tools out there. sipp, I think it's like the 20th anniversary next year, right? Yeah? So it's like from a stone age, actually, and it's still perfect, and it's still fantastic, but it sucks. But we will get into that in a second. We use sipp, a command line VoIP client that you can actually use and control, right, to do calls automatically. And it's very nice. We actually front-end that by kamailio, or you could use OpenSips as well, and rtpengine, because it's actually sipp proxies, RTP proxies, that you typically use in your server infrastructure, right? But you can very well use that at the client side as well, because you can use it as a back-to-back user agent, and you can from there programmatically change things. You can actually tap statistics. You can do all kind of weird things with that in order to get information out of your test clients, right? So you don't have to implement your own client by yourself if, for instance, sipp or sipp doesn't support a particular test feature that you need, like adding specific headers. Just put it in your kamailio config, off you go. And when we were talking about WebRTC calls, that gets even more complex, right? I mean, I remember like 10 years ago when WebRTC started, I don't know how many browser windows I tried to have open to test a call from A to B, but you only could grab one camera, so I had 2 laptops or 3, and all kind of different webcams, and it was like crazy. But what you can do instead is you can actually automate that, because there's headless Chrome out there. You can control headless Chrome with Puppeteer, and write your Selenium scripts where you just say in JavaScript, hey, go at this particular website of mine, click this login button, put in the credentials, say login or join the conference or whatever the use case is, right? And you drop into your conference, and you can, from this headless Chrome, from this Chrome internals, you can collect all this kind of metric information that you have when you manually go to Chrome internals. And then you can just pull it out and deliver it to your backend system, and then aggregate it and work with it and check if it works. So there's a lot of tools out there you can just use. And the funny thing is, all these tools, they can be remote controlled. You don't have to do this manually, because, as I said, in the middle of the night, you don't want to do it manually. You just want to punch a button and say, hey, test it, and when I'm back with my coffee, I want to have a green or a red light. So, sipp, for instance, it offers MQTT and HTTP. You can just remote control it, right? And you can program it. You can send it a curl command to do something. sipp offers UDP. You just say, do a call, increase the call rate by 10, whatever. Appium, for instance, for Android emulators in order to test your web applications. It offers a Selenium WebDriver. You can just pull in your Selenium script saying, hey, load this particular application, go to the dial pad, punch 1, 2, 3, 4, 5, punch the dial button, and then do the call, and you can actually end-to-end test your web applications with that. Fairly simple, and actually, like with a bit of a hacker mind, pretty interesting. And what you might not know is kamailio, rtpengine, they also offer MQTT. You can remote control them, you can get stuff out of there, You can tap in Kamailio and deliver all your SIP messages in raw to your backend system, to your aggregation system, even if they are TLS encrypted. Because this is actually a problem as well, right? More and more traffic gets encrypted, but when you have like access to this particular point and to the routing point, you can just go there and tap it from there. You need a little bit of plumbing in order to get this kind of pipelines running, right? So the way how we do it at Sipfront, for instance, is we have an application, and the application is basically a web application where you can say, I want to do a test. This is the system under test, SIP URI. This is the number I want to call. This is the list of users I want to put in. The call should take like 30 seconds, and the test is okay if you go through particular call states like, okay, it registers, then it's ringing, and then it's received the call, and the call got established, and you got two-way audio, and then the remote party ended the call, for instance. Yeah? So this is basically the configuration of the test. And then it gets dispatched when you say run, yeah, to SIP. We are using an AWS IoT core pipeline for that, which is actually pretty nice. Because it's very lightweight, it's actually cheap to operate. Yeah? And it can handle tons of traffic. Yeah? Like they say, I don't know, billions of messages. I've never tried that, but you know. So it goes, for instance, to SIP. SIP says, hey, I'm going to establish a call. The call goes via kamailio as like a session border controller, if you want. Right? Call goes out, system under test. It also controls rtpengine. In rtpengine, we actually pull all the metrics. We say, okay, how many lost packets per second do we have? How many bytes per second do we send? In order even to test, for instance, what happens if I use PCMA as a codec versus Opus, like, you know, how does the bandwidth change? Which is pretty important if you have questions in, for instance, in development or in web engineering in general, where you wanna, or your boss wants answers from you. You know, our customers are switching from PCMA to Opus. What does that mean for our network planning? Yeah? Do we know exactly which kind of bandwidth we have? Usually not. So we are delivering all these kind of statistics to, again, via IoT core to like a central place, AWS in our case. It goes through Kinesis. I mean, the tools, the building blocks that you have there, they are fantastic. You can build very simply, very easily, a lot of very complex call flows in like a couple of days. Yeah? You could even, from there, you know, you put it in some data lakes and apply some AI, like with Redis, you know, maybe you can have like a trigger with a Lambda function, pushing it to, I don't know, third-party applications to do more analysis on that. Yeah? But in the end, for us, it's more like the simple things. So we just, you know, we write it to Postgres in the middle, like results and metrics. We write it to ClickHouse and Loki and whatever database fits us in terms of metrics, logs, states, you know. There are a lot of tools out there that you can use. And then in the end, it ends up in some Grafana stats, and you just see them. And this is what you actually want. You just really want to visualize what's going on, because at least, I'm a very visual person. I need to see a graph, right? If I just look at the row of numbers, I'm not that autistic that I can actually make something out of that. A little bit, but the third thing is ad hoc testing, and that's a bit special because I said sipp, awesome tool, 20 years old, we are using that extensively. The good thing, or is it the bad, it has 150 command line options. Yeah, I counted them. Really? 152 or something. The thing is, you need, besides knowing all the command line options, and if you're not working day after day with these tools, you just forget about them. What you also need to do is you need to provide scenario files, right? So there's just a wall of text like XML where you have like your very specific SIP core flows that you need to put in there. And if you have a typo somewhere there, your call is broken, your test is broken. Yeah? So the thing is still, you need some kind of tool in order to reproduce these kind of scenarios, because you remember the story when I had to call my customer back then, asking her to try the call again, after thinking that I fixed the issue. Said, hey, could you please try it again? We fixed it. She tried it again, said, still doesn't work. It was a bit awkward. It gets even more awkward if you try, or if you call again and again, right? It takes you 3 or 4 times. So what you really want to do is you really want to empower your engineers to reproduce these kind of course scenarios, right? And just try it in the lab. Or ideally even hand it over to your vendor if you have a vendor, saying, you know, I was able to reproduce a customer issue, here it is, just run this command or press this button, whatever it is. And then they see it by themselves, because usually it's more like, oh really, can you send me the PCAP? I don't believe you. I was a vendor, I know how that works. So we are not writing these scenarios by ourselves, right? And I'm not expecting you to do this either. So instead, what we are using at Sipfront is a sipp scenario generator. And I'm going to try to show you a live demo. Yeah, there it is. Very simple web application that we use. And you just say, you know, what you actually want is from your passive monitoring solution, or maybe if you really don't have it, just do a TCP dump on your system. Thread the PCAP of the scenario, or if you're a developer wanting to reproduce, for instance, an actual course scenario where you took your phones, you did the call manually once, you hopefully ran the trace, you have a PCAP of this file, and then you just load this into a tool, and it says, oh yeah, there are 2,600 records in there, I found 4 cores, one seems to be a register that didn't work, maybe I want to simulate that. There's like a pretty okay-ish looking invite in there, like a core, an option, oh that doesn't look good either, right? But anyways, if you just say, you know, we are going for a basic core now, and we want to simulate that, you just say, give me the sipp scenario, and it tells you, oh, I found an invite that has been sent. I see some 180, some 200, and you can actually start playing a bit with this. So, oh, for instance, the 180, I'm not having this, so it somewhere gets removed. You can't scroll in there. But you know, you get the point. You can just start manipulating that on the UI, get your kind of verified sipp scenario out there, just press download, and you have like your finished XML. So this is basically how we try to work with this kind of tool, and how we try to empower our users to work with these kind of things.
So if you could start to wrap it up, please.
Yeah, so this is nice, but how does it help us doing, you know, programmable testing? And I was promising some curl commands in the agenda. So in the end, how that would work in our case is, for instance, if you are Twilio, or if you are a user of Twilio, and you know how to, with the API, how to generate a core, what you would do is, you would just fire a Sipfront test saying, you know, the test we're launching is just wait for call, and the only thing that the thing would do is, it would just, you know, start a PRSIP in the background, wait for like register, wait for a call, then you would do a curl to generate your core. It would route to the sipp endpoint that actually is being used here, and we would measure, okay, did the call come in, did it run through certain core steps, did the RTP get established, what was the RTP quality, what was the bandwidth, all these kind of things. Did it actually run through all the particular states that we were expecting, like ringing, established, all these kind of things. And once it's done, it will do a webhook into your system of choice, right? Because testing real-time applications is a bit difficult, so you want to have some kind of asynchronous way of handling this. And then it will post to your web URL saying, this test was good, or this test failed. And that's essentially it, right? It could get even more easy. You just do a call from A to B, and it will do exactly the same without having, you know, a certain thing. This is what you would use. You just say, okay, I have a development pipeline, and I changed my core flow for a basic core. You just run the curl, and it would tell you, did it work or not? Or you run like a run button on our website. All right, so I hope this talk refreshed a little bit your view on testing, why you're doing this, how you could do it, and the best case scenario would really be that when you leave this talk, that you sit back think a bit, okay, how do we actually handle this today? Are there things that we could change? Yeah, I'm here with my colleagues to talk to you. Maybe we can help you, optimizing your sipp and whatever workflows you have, right? Or if you need a fresh start, we're open to, talk to you as well.
Excellent. Thanks so much, Andreas.